Okay, today we're looking at writing exponential growth and decay functions. Our learning targets today are that we will be able to identify a growth or decay exponential function from a table, and that we will be able to create an exponential function from a table. So remember, an exponential function is in the form y equals a times b to the x. Okay, a represents our starting amount. And b represents our growth or decay factor, and it's the base of the exponent. Okay, and just a reminder that when b is between 0 and 1, we have exponential decay. And when b is greater than 1, we have exponential growth. So comparing linear and exponential functions. So on the left we have a linear function, on the right we have an exponential function. So if you look at the x values, each time the x value is going up by 1. Okay, in both functions. Okay, that's great. But let's take a look at the linear function. As x increases by 1 each time, what's happening to y? What's happening to y, boys and girls?
Increasing by 3.
Good. As x increases by 1, y increases by 3. So we have a constant rate of change. Okay? So with the one observation for the linear function, okay, as x increases by 1, y increases by 3. Okay, our starting amount is 2. Okay, and then let's look at our exponential function. As x increases by a constant amount, so plus 1, plus 1, plus 1, plus 1, what's happening with y? Okay, as x increases by 1, what's happening to y, boys and girls? Okay, good. It's being multiplied by 3, I heard you say. That's good. Times 3. Nice job. Okay. So let's go ahead and write that down. So you see that relationship, right, boys and girls, times 3. Okay, so for the exponential function, as x increases by 1, y increases by a factor of 3. Okay, so it's increasing by a factor of 3. And this one happens to be exponential growth. If it were, let's say we divided by 3 each time, let's just say that we divided by 3 each time, we're not, but then we would have an exponential decay function, and then we would say as x increases by 1, y decreases by a factor of 3, okay, or y is multiplied by 1/3. Okay, divide by 3 or multiply by 1/3. Okay, so what I'm going to ask you to do next is, and our starting amount here was also 2. Okay, and then writing exponential equations from a table. Compare the equation for the exponential function to the table. So compare this to its function, y equals 2 times 3 to the x power. And make a conjecture. So what do you think? It's like a hypothesis. make a conjecture on how you can write the equation for the exponential function by looking at the table. Okay, so let's take a close look here. What do we notice? We notice that our starting amount is 2, okay? And we just said in our formula, A represents the starting amount, okay? So A, if I look at my table, when x is 0, that's my starting amount, y equals 2. So this is my A value, okay? And we already said B represents the growth or decay factor, so it's times 1 or times 3. So this is my B value. Okay, as x is increasing by a constant amount, what's happening to as x increases by 1, what's happening to my y value? So being multiplied by 3. So in this case, A equals 2 and B equals 3. And that gives us the equation y equals 2 times 3 to the x. Because remember, the parent function or parent equation is y equals A times B to the x power. Okay, so then we can make a conjecture on how we can write the equation for the exponential function by looking at the table. So y equals A times B to the x is the parent function. To write the equation, or to write an exponential equation from a given table, identify the growth or decay factor okay, which is what we're multiplying, or it could be dividing by. Identify the growth or decay factor. Substitute this in for B. Okay. Identify the starting amount, or what y is when x equals 0. What y equals when x is 0. Okay. And substitute this in for A. Okay. Now, we're going to look at some very simple tables and write exponential functions given these tables. So let's take, and they are very basic level. They tell you, they increase at a constant amount each time, and they tell you the starting amount in the table. So these are pretty basic. Tomorrow we'll look at word problems that you have to read much more carefully. So growth or decay. So first of all, we need to decide, as x increases, what's happening to y? Okay, I heard lots of details. It's increasing, yes, and I heard even more specifically it's being multiplied by 2. So as x increases, y increases. At the most basic level, we can see that that is growth. Okay, and then we got a very specific answer here from the front, nice job, that as x increases by 1, what happened to y, boys and girls? It doubled. It was multiplied by 2. So multiplied by a factor of 2. Okay, so that's our growth factor. That's the b, the base of the exponent. So b equals 2. And then our a value, that's our starting amount. Well, here's our starting amount. X is 0. What's y? 8. So a equals 8. So to write the exponential function, it's simply y equals 8 times b to the x power. Or that's the exponential equation. Yes?
Wouldn't it be 2 to the x power?
Yes, thank you. Thank you so much. Yes, we need to put that 2 in there. Thank you. Sorry about that. 8 times 2 to the x. Good job. Okay, let's look at the back. Okay, number 2. As x increases by 1, what's happening to y? Okay, first of all, it's decaying, right? We see it's decreasing. It's being divided by 5 or multiplied by 1/5. Okay, so what's our base value? These are always factors, so we want, if it's divided by 5, we want to write, instead of dividing by 5, we multiply by the reciprocal, times 1/5. Okay, dividing by 5 is the same thing as multiplying by 1/5. So what is our b value? 1/5. And what's our a value? Our starting amount is 1. Okay, remember the parent equation is y equals a times b to the x power. So we will have y equals 1 times 1/5 to the x. Do I need to say 1 times 1/5 to the x? No, I can just say 1/5 to the x power. And I do want to put the parentheses in this case because I want to make sure that nobody's confused. The x needs to apply to the 1/5, not just the 1. Okay? Okay, number 3. As x increases by 1, what's happening to y? Is it getting bigger or smaller?
Smaller.
Smaller, right? 1/48 of something is smaller than 1/3 of that item. Okay, so if you think of 1/3 of a pizza, what does that look like? Think of 1/48 of a pizza, what does that look like? Okay, which slice is bigger? Okay, your 1/3 is bigger. Okay, so what's happening here?
Multiplied by 1.
Good, we're dividing by 2, which is the same as times 1/2. Nice work, boys and girls. Okay, so our starting amount is here. So a equals 1/12. And b, this is our growth factor, is 1/2. So a is 1/12. And b is 1/2. So y equals a, 1/12, times, bless you, b, which is 1/2, to the x power. Y equals 1/12 times 1/2 to the x power. Okay, is this increasing or decreasing, boys and girls? Increasing, right? 1/80th of something is quite small. 1/5 of something is quite a bit larger than 1/80th. Okay, so we have exponential growth. We're going to assume it's exponential growth. We need to see if we have a constant growth factor here. What's the relationship between 1/80th and 1/40th?
Multiplied by 2.
Good, we multiplied by 2. Between 1/40th and 1/20th, we multiplied by 2. Okay, between 1/20th and 1/10th, and then from 1/10th to 1/5, we're doubling each time. Okay, what's our starting amount? 1/20th, right here, 1/20th. And what's our b value? What's our growth factor? 2. So our equation is y equals 1/20th times 2 to the x. Okay? Okay, today we learned how to identify exponential growth or decay from a table. So today we learned how to determine whether data in a table represents linear growth, exponential growth or decay. Okay, and all of the examples that they gave us, they did have one or the other, exponential growth or decay. But we checked that by looking for, as x increased by a constant amount, did y increase or decrease by a constant factor? And these all did. But what if I had a times 2, times 3, times 4, times 5? Would that be exponential? No, we would need a constant factor. Okay, so if the data in the table was exponential, we learned how to write the exponential function from that table. And technically we're looking at equations. Oh, I erased decay instead of function. This should be equation. Decay, equation, sorry. Thank you. Okay, sorry about that. And please rank your understanding level, your confidence level on a scale of 1 to 5, and then explain why you have that level of ranking. Thank you, boys and girls.